Hey folks, we doing all right? Yeah, it's a couple of minutes before we start properly. But for any of you who haven't figured out, I'm not Martin Widlake, who was supposed to be up here earlier. Um, so unfortunately, if you're hoping that this is going to transform your life and going to make it much better, sorry, this isn't the presentation for you. Unfortunately, yesterday I got caught out with some weather. So this was the view over Stansted Airport yesterday. So unsurprisingly, my flight was cancelled yesterday. So I've had a bit of a journey getting here. So that's what Martin kindly agreed to switch with me. So that's why I'm now instead of 3:30 as originally advertised. So I haven't actually seen much of the conference so far. People enjoying it so far? Yay, cool. Oh, this is sounding good. Favorite event so far? Favorite presentation? Keynote. What was the keynote about this morning? Architecture. Okay. Software architecture, right? Yes. Good. Buildings. Yeah. No. Okay. So we'll get going in a second or two. It's not quite time. Give some stragglers a second moment to turn up. So let's. These lights are really blinding that come in with the spotlights. I'll get some sunglasses to. You can. I won't be able to see. Well, I'm sure some stragglers will turn up at some point, but we may as well get started properly with the last session of the day. So I don't want to hold you too long because I'm between you and beer. So I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team. It's my job to help you get the best out of Oracle Database and hopefully have a little bit of fun whilst doing so. So with that in mind, I'm going to be talking about some of the cool new things that are in Oracle Database 18c to help you build better, faster Oracle Database applications. Standard disclaimer before we begin, let's get started. Now, at this point, some of you might be thinking to yourself, hang on a second, wasn't the last version of Oracle 12c? What happened to versions 13 through to 17? Have I fallen asleep for 10 years? Has Oracle gone into some kind of time warp? Well, what's going on? What's the system here? Well, the good news is you haven't missed anything. This is all part of a new release process. So there's going to be a new full version of Oracle Database every single year. And the number of that corresponds with the last 2 digits of the year. So we've got 18c this year. Next year we'll have 19c. Year after that, we'll have 20c, and so on. So the good news is you're going to get more features more regularly. However, it's going to make these kind of end things about version N talks a bit more challenging. There's going to be a lot of content to get through. Another thing worth bearing in mind is that for most of 18c's life, it was actually referred to as 12.202 internally. So I might cheat a tiny little bit and cover some 12.2 features in this talk as well. They will be posted on the slide so you can see what is what. That's enough from that. Let's talk about some real content. And we'll start by talking about one of my favorite features of Oracle Database. That's external tables. So these are a great way to use SQL to read files into your database, but they can be a little bit fiddly to work with. So quite often, you've got these files that are an export from an external system, and you have a daily or weekly job to import them. And so those files are stamped with the date in them like this, which is a bit of a problem because the external table points to a particular file. You can have it go to multiple files, but that's not great. So you kind of go through a process of every single day pointing at a new file. Or you can kind of munge the file and convert it to a standard name and then convert it back afterwards. But neither of these approaches are particularly good because it's a bit of a faff. You don't want to have to be running DDL on your table so you can point at a new file every single day. And just renaming files is a bit of a pain and a hassle to deal with. It would be better if you could just temporarily point the external table to a new location, point it to a new file. So this is what we enabled in 12.2. We introduced something called the external table parameter override, which allowed you to do exactly that. It says, here's your external table, point it at a new directory or a new file, and so on. And you do that with this external modify clause. So you can change the directory location, log files, and reject limit. So if you've got this process where each day you're pointing it to a new file, you can go, okay, so the first day, 1st of January, we're pointing at that. 2nd of January, we're pointing at that. 3rd of January, we're pointing at that, and so on. So now you can kind of dynamically repoint the file. So this is something that I wish had existed about 5 or 10 years ago when I was doing a lot of data warehouse importing, but now we finally got it. So that's all very well and good. It makes it nice and easy to work with these changing file names, but what if it's not just the file names that are changing? What if the actual structure of the file changes? So maybe you get daily files during the week, but you get one file for the weekend combining Saturday and Sunday, and that has an extra column in it with it for the date. Or maybe month and year end, you get some extra summary columns or different details in that file. That's a bit of a pain because then you've got different external tables for different files for different days, which just makes your code a little bit messy. So, it would be this is a bit tricky to deal with. And sometimes what people might kind of go is, well, rather than trying to set up individual external tables for each one, what we can do is just load everything into a nice big long fat string. So we'll do that, and then we can select it out, and all the information's there. Of course, okay, we've done that, but you still got to parse this out. You still got to split it out into all its individual components. So, how do you do this? And this is where things get a bit ugly in Oracle database. So you can go to like substring hell as you try and figure out which exactly column you're going to rip out, or if you're brave, you can start playing with regular expressions. Either approach you take, if you've got different number of columns in each file, you still got a fixed list of columns. And if you want the actual column list to change for the file, you're going to have to fall back on some dynamic SQL. So these are all a bit fudgy solutions. However, 18c introduces another way you can tackle this problem: polymorphic table functions. So this is one of these slightly bizarre sounding features, but what it enables you to do is manipulate the structure of your output. So you can add or remove columns dynamically based on the input. So if we take a simple example, I've got a CSV to columns converter, PTF, and we pass in our table name, external table, and I want 3 columns out of it, 1, 2, 3. Now I've changed my mind. I actually want, or I'm pointing it to a new file, I want 4 columns. I can just add that 4th column there. So using this PTF, we can add or remove columns from the output. So how do we do that? Well, there's a couple of things you need. First up, you need to create a package. So this is the engine of your PTF. This defines the actual structure of the output and what the values are going to be. So you do that with a couple of features. First up, you have a describe function. So this tells the database which columns are going to appear in your output. And you can also remove columns from your output as well. So you want to suppress date columns or something like that. So you can completely free to do whatever you want and manipulate the output. So that tells you what there's going to be. You've still actually got to assign the values for these columns in each row if you're defining new columns. And you can do that with this fetch rows procedure. Technically, this is optional, but if you're defining new columns, I struggle to think of a real case where you wouldn't have it. So this is the engine. This is the implementation details of your PTF. The next thing you need is the actual function itself. Now, you can place this within the package, or you can create a standalone function like this. So we've got this row, it could be table as well, polymorphic, and see, we're using that package that we just defined. So that binds it to the implementation we just had. And so this is a big feature. There's a lot of detail in it. So what I just wanted to do very quickly is show you a brief example of how you might do this. So we've got a new PTF package implementation, and what we're going to do is add some columns into our output. So just 3 columns. I haven't defined a fetch rows procedure, so they're just going to be null. So if I create a PTF called add 3 cols, we get those in our output. So as I say, this is a very big feature. If you want to know more about it, there is a lot of examples in the docs. I don't really have time to go in more detail on it now. You might go, well, what's the use of this? Well, CSV to columns converter is one of them. Dynamic unpivot is another example we've got. Sadly, we don't support dynamic pivot as yet. Hopefully that will come in a future version. So as I said, this is a complex feature, but let's just jump back to this describe function. And some of you may notice something a little bit interesting on this. And that's these values here. So we've got these 1, 2, 3 here. You might be going, well, what are these? Because they can't be parameters, the names of parameters to a procedure or function, because they are numbers. And unquoted identifiers in Oracle database must start with a letter. So what on earth are these? Well, these are another new feature in 18C. That is qualified expressions, also known as array or record constructors. So what this allows you to do is have a single statement to initialize a record or an array. So let's just see what exactly that means. So in the past, we got our table indexed by varchar2. If we wanted to assign 3 elements to it, you would have to do 3 individual separate statements. Bool VC array now has an implicit constructor as part of it. So you can now do something like this. So now that's just one single statement which assigns all those 3 values. Like I say, this also applies to records as well. So you can have a record with lots of different attributes. In the past, a whole bunch of different statements for every single one. Now we have a single constructor which does the whole thing. So nice little simplification feature for you. Now at this point, we've kind of gone off a bit of a tangent, right? We started talking about dynamically changing the columns for our files we're reading based on the file. And some of you might be going, what on earth are you talking about here, Chris? You know, polymorphic table functions, qualified expressions, what are you doing here? All I want to do is just change the output based on some input. I could use dynamic SQL to do this. Well, if we're sticking with external tables, there's actually now another approach you can take in 18C, inline external tables. So these are external tables which literally only exist for your query. So they have no formal definition in the database. So what you can do, we got this keyword external, and then you literally paste in the names of the columns you want and your external table definition. So we can start with this, say 1 column. The minimum we need is a directory and location. We want 2 columns, we just add that in. So this is a handy little feature. You know, if you do a lot of ad hoc analysis on lots of different files, it means you don't need to create a table every single time. Also potentially useful, read-only environments. People quite often say, oh, I don't have permissions to create tables, but I need to read these files. How can I do it? This option opens an option for you. And it's also useful kind of prototyping these files as well. For complicated files that aren't straightforward CSVs, it can be tricky to figure out exactly how to get the access and parameters clause right. So this allows you to prototype it without having to drop and recreate the table every single time. So this is pretty handy, but at some point, you pretty much always want to take that file information and stick it into a real database table. And I'm feeling lazy, I don't want to list out all the columns for that table. How can I ensure that the columns here match the external table definition? Right, well, there's something else in 18C which might help here. Private temporary tables. So any of you who've come from a SQL Server background will be familiar with this concept already. So these are tables which only exist in a session. And we do that with this private temporary table clause. Note this slightly cryptic $or $PPT prefix. You have to specify this, and it has to match whatever the private temp table prefix parameter is set to. Otherwise, this just isn't going to work. Once you've done that, this definition only exists in memory and is only visible to your session. So no one else can see it. It is not written to the data dictionary. So if you try and query user tables, user tab calls, or whatever, you're not going to find it. So your code kind of has to know it's there. What this also means is that 2 concurrent sessions can create the same private temporary table with a different definition. So they could actually have completely different structures, should you wish to, for whatever reason. So we can create it, we've inserted it, and that all lasts and persists until we commit. And then what happens? Table's gone. Okay. Well, those of you who are familiar with global temporary tables, it's a similar concept there. We've got this on-commit clause, and we say, by default, when we commit or you roll back, so you end in transaction, we drop the definition and the table's gone, so it doesn't exist anymore. If you need to keep it across transactions, then set it to on-preserve. Whatever you do, as soon as your session disconnects, that table is gone. So make sure you save it into a real table before doing this. So let's move on. And quite often when people are dealing with these kind of dynamic files or things where they're not really sure what the structure is going to be, they resort to JSON. So they can say, you know, we're going to flexibly add or remove attributes. So what I just wanted to do is give you a brief tour of JSON in Oracle Database, starting with back in 12.102. And we introduced some functionality here for when you're storing a JSON document directly in your database. So we created this isJSON check constraint that allowed you to use simple dot notation access to access the values. But there's kind of an issue here. So we've got this thing, we've got an array of employees, one department, 2 employees. If we're querying that, quite often you might want to see it in kind of traditional row and column format like this. But how do you do that? We've got one document, one row. How do we get individual rows out of it? Well, in 12.102, we also introduced this JSON table function. What that allows you to do is kind of explode out that JSON document into its relational format, rows and columns. So this is kind of handy, but it's just, it's a bit clunky. It's a bit verbose, right? There's a lot going on here. And we've doubled up on a lot of things. So we've got the column names on the left and the attribute values on the right. And they exactly match, which is a lot of wasted typing and kind of breaks one of the key development principles of don't repeat yourself, right? We don't want to have to be double typing things like this. So we looked at this in 18C and simplified it a lot. What you can now do is just specify the attribute names, and it will implicitly create columns with that same name. And how does it know where to find or where to look in the document? Well, we've got an implicit path based on the route you've taken through the document. So it's just a little simplification feature, make it easier to convert these JSON into relational formats. So this is handy, but personally, I think most of the time, if you're receiving JSON, what you should be doing is shredding it and storing it in its relational format. This, however, brings the opposite problem, right? We've got our relational tables. How do we get that back out as a JSON document? And this is tricky for all but the most trivial of JSON documents. So in 12.2, we introduced a whole bunch of JSON functions to enable you to do this. These array and object ones and the ag. So what do they do and what they mean? Well, quite simply, the array ones give your output with the square brackets, and the object put the curly brackets around it. And ag versus non-ag. For the non-ag versions, for every row in your input, you'll get an array or object in your output, and the aggregate can combine many into one. So it makes it quite easy to generate a JSON document. So if we look at our thing here, we've got each department is its own object, and it's got an array of employees in it. How do we generate that? Well, we can use a query a bit like this. So we start from the inside out. Each employee is their own mini JSON object. So we've got the attribute values. We're array agging those together so they become one array, grouped by department. And then finally, we slap the JSON document around that. So makes it much easier to generate these. But they were a bit limited in 12.2. They only supported some basic data types, which is basically number, string, and date. So in 18C, we've enhanced these so you can support a lot more data types as input. So pretty much every data type in Oracle database is now supported as input, and you can now return it as a glob or a blob as well, making it these functions much more useful. So let's say we're taking a JSON document, we're shredding it and storing it in relationally. It's pretty certain that at some point you will want to convert your relational rows and back into the same JSON document. So you're going to take something in and want to get the same thing back out, which brings the important question. Are these the same? Now, at first glance, these look completely different, but most of this is just white space formatting, and anything outside the attributes doesn't matter. But also, you can see on the left, we've got the department attribute on the top, but on the right, it's at the bottom. According to the JSON standard, this doesn't matter. These are, in fact, the same JSON document. So this makes comparing these really, really tricky. You can't just go for straightforward string comparisons. You've got to get a bit creative to do that. Until 18C, we now have a JSON equal condition, which basically you pass in two JSON documents, and it tells you whether or not they're the same. So if we do that, we see we've got our two documents here. Notice I've also got this little treat as JSON. So another little thing that's crept in 18C, it says, consider the contents of this to be a JSON document, which can be useful in some situations. So we're saying, are these the same? And it is ignoring insignificant white space, so anything outside the attributes or the values. So the spaces for Shelley, Higgins, that matters because it's part of the value. but everything around outside the quotes doesn't matter, and attribute order. So the order of array elements does matter. So if we switched Shelley and William around, there'll now be different documents, but you can see we've got the department in different location. That doesn't matter. So this now massively simplifies the process of comparing these documents. So let's move on, and we'll kind of stick with JSON a bit. So as I said, quite often people are taking JSON and storing it in their database, and this is something which is actually really common with kind of Internet of Things applications. You've got lots of little tiny devices, and they're sending JSON payloads to your database. And all you're doing is taking that JSON payload, assigning it a primary key, and storing it in your database. That's it. So this is all very well and good, but there's potentially a couple of issues here, and they relate to this sequence here. So we're using a sequence to assign the primary key. If we've got a lot of these devices, hundreds, thousands, maybe even of millions of them, we could have a lot of concurrent sessions. So a lot of people at the same time are trying to generate the value and dump the JSON in the database. So we can have some contention on the sequence itself. So this could become an actual bottleneck. Now, you can help reduce this by increasing the cache size, but there's still another problem here. So this is going on the primary key. And our primary key has an index on it. Because these values are always increasing, pretty much all those values are going to go in the right-hand edge of that index. So they're all going to go in the same block. Again, this can lead to a lot of contention here. Everyone's trying to access this little block on the right here to insert the sequence values, can slow down the throughput of your application. So we want to avoid that and actually have the values spread throughout the primary key index. Now, there are a couple of ways around this. So you could use reverse key indexes or hash partition that index, but they both come with their own drawbacks, and they require you to rebuild the index. Not something that kind of gives you a nice, warm, fuzzy feeling on your 10 billion row table that for an application with 24/7 by uptime. So you probably don't really want to do this, or people put this off as long as they can. Well, 18C offers another way out of this pain, and that is scalable sequences. So a slightly interesting name. I always thought sequences were supposed to be scalable anyway, but there we go. That's what we've called it. What this does is it offers a couple of extra options for when you create a sequence, and they are these scale and extend keywords. So we'll start with scale. What this does is adds a 6-digit prefix onto your sequence. So if we create this sequence and we get the values out, we can see we've got our 6-digit values there, and they are generated from the instance number in rack and the session ID, making it very unlikely that two concurrent sessions will have that same prefix. The actual values for that sequence are these ones out here. So this can make it a bit fiddly to actually get the real sequence values. If you've been relying on those primary key values for anything in your code, you're going to have to think a bit carefully about what you're doing if you're going to use this. So that's scale. It adds the 6-digit prefix. What's with all this extend? What's that doing? Well, by extend, it adds these 6 digits on top of whatever the maximum value of your sequence is. So if your sequence is 10 digits long, the max value of it, if you extend it, the number you'll get will be 16 digits long. If you set it to no extend, those 6 digits come within the max value of your sequence. So you can see we've shortened our sequence values quite significantly. So what this means is you have to have at least a 7-digit max value for your sequence. And if you've only got 7 digits for a max value, you only actually get the values 1 to 9 out of the sequence itself. So something to be aware of. It's probably not a problem for most of you, but something to watch for if you set a max value and cycle your sequence around. So let's kind of stick with performance and return to external tables. So like I say, they're great, but again, when it comes to performance tuning on them, your options are quite limited. So let's say we got this colossal file here, and actually we're only interested in a very small subsection of it. Well, how do we make this process faster? There isn't a huge amount you can do, actually. You can't create an index on it, so to identify those. So basically, you've got to load the whole file in and then create your indexes or whatever before you can do any optimization on it. 18C offers another approach. So you still got to load it in, but you can now load it into the in-memory column store. So any of you who are lucky enough to have in-memory can take advantage of this. So How does that work? Or what does that do? Or how do you do it? Well, quite easy. You set it in memory and then populate it. So you do this, you've loaded it into it in memory, and you run your query and you find that we still got our external table access full. You might go, well, hang on. I thought we loaded it into the in-memory column store. Why aren't we getting in-memory table access full? What's going on here? Well, this point, it's important to take a step back. So external tables are outside the control of the database. Anyone at any point can come along and just edit the file, add some rows, change some information there. And the database doesn't know it. So once they've saved that, nobody knows that it's changed. And in order to get those changes, you've got to reload it in. And then by default in Oracle database, we assume that you want the most up-to-date correct information. That information in that in-memory and column store might be out of date. We don't know because we don't know who's been fiddling with it. So we say, well, we don't allow that. So how can what are we doing with this feature then? How can we get out of this? Well, there is a workaround that's actually existed for a long time, and any of you who've used materialized views will be aware of it. And that is the query rewrite integrity parameter. So this is something where you say to the Oracle, the database, you're saying, well, I know that data might be out of date or is out of date, or I know it is up to date, but I don't care. I want the performance gains I'm going to get from using the in-memory column store, or in the past, materialized view. So use it anyway. So by setting this to stale tolerated, you get that nice in-memory full table access. All very well and good. Everything's hunky-dory, unless someone stuck a no in-memory hint in there. You're like, and this is a pain, particularly if it's a third-party application or other code that you can't easily change. BI tools in particular seem really fond of spraying hints throughout their code, or the SQL. And if you can't, like say, if it's a third-party application, and you can't figure out which knobs or twiddles to flick to actually disable the hint, or you can't get the vendor to turn around the change quick enough, you're kind of stuck. You've got these nice performance gains, you're not able to use them because somebody stuck a hint in there which disables them. I mean, this is one of the reasons why we say don't use hints. There may be future optimizations which you're preventing by doing this. But so you're kind of stuck. If you can't change the code, how do you get out of this? We've lost our performance gain. Well, 18C offers another option. You've now got the ability to ignore optimizer hints. So just a simple alter session. Set that to true, and the database will optimize it as if those hints did not exist. So it strips them out and then optimizes the query as it would without them existing. We do that, and we get a nice in-memory access full again. So, talked about performance, something a lot of people care about. Let's talk about something else that hopefully you care about. That's security. When you're developing your applications, it's important that you make sure that people aren't doing things that they shouldn't do. And in order to follow that, you should follow something called the principle of least privilege. So actors should have the exact and only privileges they need to do their job. You shouldn't just give people things like the DBA privilege just in case you want to figure out how they can do what they're going to do. You want to give them the minimum privileges they need. And when it comes to building applications, what does this mean? Well, you've got your application, and it should connect to the database as the lowest privilege user possible. And so it should have as few privileges as it can, and importantly, it should own no objects of its own. Excuse me? Why? Well, if there's tables in this schema that we're connecting to, you've always got full permissions on your own objects. So you can always query them however you want. You can insert, update, delete them. And if you're feeling particularly mischievous, you can drop them. So if there's some kind of vulnerabilities discovered in your application, then someone can come along and do all sorts of untold damage. So you want your tables in another schema, ideally behind a PL SQL API, so you can control exactly what you do. I believe this was what Bryn was talking about earlier today. So you can tell you more details on this if you want them. So now we've locked down the application. Even if some vulnerability is discovered, people can only do what we've allowed them to do. Okay, they might still be able to cause some damage, but we've limited it drastically. We've locked the front door, but there's still a back door. Someone is able to gain access to your network. They can always potentially find a way to run access through SQL Plus or whatever, and connect to that schema directly. And this is actually kind of tricky to stop. Hopefully you've locked down your network, but that can be difficult to do. So how do you stop this? Well, the simple answer is you say, well, let's lock the account. So that way no one can connect to it. That's one of those easy to say things, but actually can be really easy to overlook in practice. It's easy to forget that you should have locked that account and you didn't. Let's say there's some Friday afternoon emergency. You're going to go in, run some scripts, get everything running. It's late by the time everything's sorted out. You go home and you forget to relock that account again. The account's exposed the whole weekend. A particularly ingenious or creative hacker might actually be able to engineer this kind of situation to give them time to do whatever they want to do. So there's some limitations to this. It has some process limitations, but there's also another potential problem. So if you lock an account and you try and connect to it, it doesn't matter what password you supply, you'll be told the account is locked. So now I know I'm a hacker. I know data owner exists. I've learned something about your schema, so I could potentially use that in any other hacks I'm going to try and do. Now you might say to yourself, well, my schema is called something a bit cryptic like XYZ owner or something even more bizarre. The chances of someone figuring that out are pretty low. Yeah, maybe you've got an argument there, but there's still potentially a problem. If you've got some of the Oracle supplied schemas installed for things like Oracle Text, Spatial, XMLDB, and so on, they have some of the more interesting vulnerabilities available to them. So if I'm a hacker and I'm going, well, have you got Spatial installed? Oh, yes, you've locked the account. I now know, and I can look up the vulnerabilities related to that. So you don't want to leak this information if you can avoid it. You don't want to tell people that this account actually exists. So what can you do? Well, 18C offers another approach, schema-only accounts. So these are users with no password. There is literally no way to log into as this user. And you do it with this no authentication clause. So I've not defined a password. I've defined no way to connect to the database as this user. And what that means is if we try and connect to it now, we get the invalid username or password. I don't know what's wrong here. I don't know if data owner exists and I got the password wrong, or if the schema doesn't exist at all. So we're limiting the information we're leaking out to our application. So at this point, some of you are probably scratching your heads a bit and thinking to yourself, well, this is all very well and good. We stopped bad guys getting in, but how do I get in, right? I've got to deploy my scripts to this. How do I do this? Do I have to go in and supply a password and then unauth it again afterwards? It's like, well, you can do that, but that's the kind of lock-unlock problem we were discussing before. It's easy to overlook it. There is an alternative. You can use proxy users. So these are low-privilege users which have the ability to connect as or through your high-privilege accounts. So when we do this, don't know the data owner's password, and in fact, doesn't even have a password here. But when I'm running as proxy owner, I've got the privileges of that user. So this is a way we can approach this. So that's all very well and good, but there's still some things you need to watch for here. So you set up the proxy user, and your DBA or production support team are all connecting through that proxy user. That introduces a couple of problems. One is, how are you sharing this password? Hopefully, it's something a bit more secure than the old post-it note approach. So you need to make sure you've got a good, secure way of sharing passwords. But even if you've done that, you've come up a nice way making sure that only people who can see passwords are supposed to, there's still a problem. You've lost the identity of who does what. Let's say one of your DBAs logs in and does something they shouldn't have done, like drop some tables. But they've all come through the same proxy user. So when you sit them down and say, well, which of you did this? And they all go, well, you can't prove it was me. So, right, I'm fine. So you don't want to be in this situation. You want to be able to identify who does what. You want to know who carried out which particular actions. So you want to avoid this approach. What you can do is set up proxy users for each individual person. So we've restored the identity. We know who does what. But in some ways, this kind of moves the password problem around. You're now leaving it down to individuals to come up with their own password saving process. And you know what people do. There's always someone who has the post-it note on their monitor or whatever to do it. And this isn't good. We've all got, hundreds, maybe even thousands of accounts which we need passwords for. We don't want to start adding our production support team with more passwords. You don't want to burden them with more passwords than they really need to. And the thing is, most organizations already have a nice centralized place to handle all this, your password policies, identity management, and so on. That's Active Directory. It'd be kind of nice if instead of doing this, we could just authenticate against Active Directory instead, right? Well, the thing is, you've actually been able to do this for a really long time. There's this thing called Oracle Directory Services, and you can stick that between the database and Active AD and do that mapping. So it does the authentication and management there. So that's all very well and good, but no one really wants to do this. It's another thing to set up and configure, and license implications and so on, thing to back up, make sure it's running, what if it goes down? It's just generally a bit of a faff, and most people just didn't bother. So 18C, we've cut out the middleman. We've now got direct Active Directory integration. So instead of Oracle Directory Services, we can cut that out and go straight to AD. So now you can map your database users directly against AD users and do all your authentication there, simplifying the process of authenticating and identifying who people are. Hang on, come to that in a bit. So let's move on and talk about something completely different. So let's imagine you work for a retailer, and that retailer sells books. And I'm going on, and I want to search for Oracle books. So I type in Oracle, and I get a bunch of hits back. So this is my results here. So this is all very well and good. But if you are a large enough retailer, there's a chances are you sell a whole bunch of other products which include Oracle in the title. There's a whole stack of films, songs, computer games, and just a whole bunch of weird products. Things like Mystic Tarot cards. You can get a little unicycle which has got Oracle in the title. Extractor fans. It's a fairly common name. And for even more common words, for search words, there could be a whole stack of these kind of categories. So to help your users, what you want to do is show them the different categories and how many products match their search. So the number in brackets is how many different products there were that contained Oracle in the title. And like I say, if you are a large enough retailer, there could be a really, really long stack of these categories. So you just want to limit it to the most popular, because chances are that's what the user's searching for. So you just want to do a kind of top end by count. So how do you do this? Well, this is fairly straightforward and fairly easy. It's a two-step process. First up, we just search for the products, group by product type, category, and then do a top n of those. So we get the first 4. So that's fairly easy to do, but there's a potential problem with this. So if we look at the execution plan, that first stage where we're grouping, we got this hash group by. You might go, okay, well, what's the big deal? What's the problem with that? Well, if the number of rows this hash group by is processing is large enough, it could have to start having to write that to temp. So start reading and writing it from disk. As soon as you start having to read and write from disk, the throughput of your queries will fall drastically. So the response time is going to be a lot slower. And so that's not good. And the bigger problem is that as a developer, you don't really know where this cliff is coming. We know that one day, if there's enough different categories, we might hit this point where we start writing to temp, but you don't know when it's going to come. And even if it does happen, you have to get really creative with your SQL statements to avoid it. It's just, it's not good. There isn't or traditionally, there wasn't a good way around it. Well, 18C offers another way around. That is approx top n queries. So these are approximate queries. So instead of a count, you can now have an approximate count. And now this is a top n query, which means we need to have this lovely having clause. So we're saying sorting it by the count descending, limit it to the top 5 of those. And we get those rows results. So this having clause is mandatory. So you need to use it. We can't just do a straightforward count or approximate count. So like I say, these values are approximate. They're typically over 99% accurate. Probably good enough for something like your customer search screen. I wouldn't rely on it for your customers' financial reports. So just bear that in mind. So this is all very well and good. And the thing is now we've eliminated that hash group by step from the operation. So the good news here is it's one less thing we're doing. So all other things being equal, we're going to be a bit faster. And what's drastically less likely, we're going to have to start reading and writing from temp. So we're less likely to hit that kind of performance cliff. So that's all well and good. But the chances are when you're offering your customers ways to search and filter your search results, you don't want to have just one thing. There's a whole bunch of things you'd like to be able to filter on. Things like customer review, when it was published, manufacturer, publisher, that kind of thing. So there could be a whole stack of these other categories that you want to filter on. And for each one of those, you're going to have to write a new query to the database. So potentially you can have 6, 7, 8 of these, depending on how many filters you want going to the database. Potentially adding a lot of overhead to a lot of round trips to your communication with the database. The other problem is, for some of these categories, you don't want to sort them by count. So things like customer review. So if we've got our customer reviews, they've got a 1 to 10 scale, you don't want to show the review that has the most hits in it first. So if most people have said this is an 8-star product, you don't want to show that at the top. You want to do it strictly 10 down to 1, right? It's just confusing otherwise. So some of these things you'll want to sort strictly by value rather than by count. And Approx top N doesn't really help here. Luckily, 18C offers another way out of this. Oracle Text Faceted Navigation. Yeah, we're great at naming in Oracle, aren't we? So what does that mean? Well, what it allows you to do is define columns which you can search or sort your data by. And you can then do that on a group of these with a single call to the database. How do you do that? So if you like the name, you're going to love this bit. Just a nice simple call like this. Some lovely XML. Oh, fantastic. All right. Okay, well, what we're saying is we want the top 3 products by count, and we're looking for the top 3 ratings by value. So when we do that, well, we've got XML in. What do you think you're going to get back? XML. So we've got our actual rows here, and then you can see we've got our top 3 product types in the XML we're getting back, and our top 3 ratings. So maybe a bit clunky, a bit fiddly to work with, but the point is you're making one call to the database, so it's a single round trip rather than having to write several different SQL queries. There's a lot of other power in this as well. It's worth checking out if you do a lot of kind of free text search on the database. So we've covered quite a lot of things here. And hopefully you've seen at least one thing there and you thought to yourself, that's really cool, that's useful, I can see how this will benefit my applications. So, as Andres was saying, how can I get my hands on it? How can I start playing with this? So currently, 18C is only available on Oracle Cloud and Engineered Systems. The on-premises release is due in July, so not too far away, so not too long to wait. In the meantime, if you want to start fiddling with it, there's this fantastic tool called Live SQL. So this is a free browser-based tool you can use to run and log in and run SQL scripts. And as I've highlighted, this is all running on 18C. We've also got a whole bunch of scripts loaded in there demonstrating the new features. So pretty much everything I've talked about so far does have a script in there. Doesn't include everything. Some things like external tables don't work, which kind of makes sense because you've not got access to the file system of the database, but most things are in there. So you can have a fiddle around, see how these things work while you're waiting for the on-premises release. And if you like free, and if you like that, you're going to hopefully love this. XE. Every full release of Oracle Database will include a release of XE as well. So, and XE will be a limited version of Oracle Database. So you can only have 2 CPUs, 2 gigabytes of memory, and 12 gigs of disk, but it is it's compatible with EE and includes most of the database options. So things like diagnostics and tuning. It doesn't include everything. Things like rack are not included, which kind of makes sense because you can only do it single instance. I do need to kind of go safe harbor at this point. It's not ready, but this is what we're planning. This is due after the Windows release of the on-premise. So we've got July. We should have the Linux distribution on-premise of 18C. About a month after that, we should have Windows, and XE should come shortly after that. And this is 100% free. This is free for you to use however you want. You don't need any licenses for this. So you can do whatever you want with XE. And like I say, it is basically a limited version of EE. Some of you might going, okay, well, where's the catch? What's going on here? There is no support for this. Okay, so if you run into trouble, you're on your own. That also means there is no patches for it. However, there's going to be a new version of it every year. So you're not going to have to wait for this, we're still on 11.2 of XE, I think, at the moment. So you're not going to have to wait quite so long. You can keep more up to date with it. So we're getting towards the end. At this point, just highlight another little feature. Some of you may know the sleep function always used to exist on DBMS lock. We've moved it to DBMS session. So I'll just sleep and pause the presentation for a minute while I take some questions, because we've got a couple of minutes. Yeah, welcome. Just shout.
No. You need microphone for the recording.
Need it for the recording. Well, I'll say it back. Okay.
Thanks. The question is regarding these polymorphic table functions,
yes,
which you mentioned. There already is a possibility to define columns dynamically using the data cartridge and or the CI.
Yes.
This kind of stuff. Are these two things related somehow, or?
No. So the existing Oracle data cartridge, which allows you to kind of build your own functions, essentially, that's what you're talking about?
Yeah, table functions with any data set, any data or any type.
So there's a couple of important differences that polymorphic table functions have. One is you pass in the actual table as a parameter to the function, and then it allows you to inspect the columns and values for it. Second thing is you can actually pass in a list of columns as well. So you can say explicitly, I want this list of columns from this table to be in the output. There are various other differences which are kind of getting a bit technical and beyond what I can really cover in 30 seconds. But this, well, similar to killing a session, you find the session ID and serial number, and then do an alter system cancel SQL. And at that point, you'll, instead of being killed, you get the 1013 error. Okay, you still get an exception, but the point is your session still exists and you can continue processing once you've handled that application. So at this point, I kind of want to wrap up.